Hello, today we are going to start learning about exponent properties. So for today's first lesson, we are going to talk about the different power rules that we have when dealing with exponents. So these will apply when we are multiplying or adding terms that have exponents in them. And the first rule that we're going to look at, rule number 1, is called the product of powers. So this rule happens when you have some base raised to an exponent and then it's being multiplied by the same base to a different exponent. So as long as the bases are the same, they have to be the same number or the same variable, what we do with their exponents is we add them together. So when multiplying two terms, two monomials with the same base, you're going to add those exponents. So here m plus n. So for example, if I have 4 squared and I'm timesing it by 4 cubed, they both have a base of 4. So then that means we can take the 2 and add the 3 and we get, wow, I can write 4 to the 5th. So another way to think about it is 4 squared, that means to do 4 times 4, right? And then 4 cubed means to do 4 times 4 times 4. So total, if I write out all of those 4s, I have 5 of them, which equals 4 to the 5th. So this is really just a shortcut, the adding part, so I don't have to write all of the numbers out every time. I can just add the 2 and the 3 to get 5, so it's supposed to save you time. So same on number 2, they're both the same base of x, so when that happens, we can add the two exponents together, so 3 plus 4, and that gives me x to the power of 7, and that would be my answer. So hopefully that makes sense. Just make sure that they have the same base whenever you're doing it. They have to be the same number or variable. Okay, let's try some more that might be a little bit more difficult. So here we have c to the 6, and I'm timesing it by c to the 7. So again, same base. So that means I can just add the two exponents. So 6 plus 7 is 13. So there's that one. Let's look at this one. We have some coefficients now. We have a coefficient of 3 and a coefficient of 4. So when that happens, you're going to times the numbers together. So kind of think of grouping the like terms. So 3 and 4 are going to be times together. And then we're going to have the c to the 3rd times the c to the 7. So I'm kind of just grouping it. And then we can do our multiplying. So 3 times 4 equals 12. And then since these are both a base of c, we can go ahead and add those exponents. So 3 plus 7 is 10, and we get c to the power of 10. And that would be our answer. Okay, on this one we have a coefficient of 3, and then this one doesn't have a coefficient. It's technically 1, but we just don't write it. So I don't have another number to times with the 3, so I'm just going to keep it a 3, but then for our base a's, we can add those exponents. So 6 plus 8 is 14, so we get a to the power of 14, and that would be your answer. So that is the product of powers. That's what you do when you have the same base being multiplied, and remember, product means multiplication. The other rule that we're going to do is called a power of a power. And sometimes I get students confusing these two rules. A power of a power is when you have one base raised to an exponent, but then raised to a second exponent. So you have this little exponent m, and then it's raised again to an exponent of n. So it will have these little parentheses around it and a double exponent with only one base. So when you run into a situation like this, instead of adding the two, we're going to multiply them. So kind of think of timesing those two exponents together. So you get m times n. So on this one, for example, we have x cubed being squared. And I'll write it out the long way because sometimes seeing the visual of this helps a little bit to understand why we do the shortcut. If I have x cubed and then I'm squaring it, whenever I square something, it's saying to take whatever is on the inside and times it by itself. So really this means to do x cubed times another x cubed. Well, if I write all of that out, x cubed would be x times x times x, but then I have another x cubed, so I have another x times x times x. That's a total of 1, 2, 3, 4, 5, 6 x's. So I get x to the power of 6. So rather than writing all of this out, we do our little shortcut where we just times the two numbers together. We get 3 times 2, which equals x to the 6. So again, these are shortcuts so that you don't have to write all of these things out, which it gets really annoying, especially if you have really high exponents. 2 and 3 aren't too bad, but say you had a power of 10 or a power of 20. You don't want to sit here writing everything out every time. But hopefully that visual can kind of help you to remember the rule. So here on this one, we have 2 to the power of 4 raised to another power of 3. So we have a power of a power. So we're going to times those two together, and we get 4 times 3, which is 12. So we get 2 to the power of 12. Same on this one. We have 1 base raised to a power raised to another power. So a power of a power. We're going to times those two together, and we get a to the 2 times 4, which is 8. And that would be your answer. Okay. So sometimes we have 2 bases inside of parentheses, and this is what we call a power of a product, since we have a product of bases with a power on them. This is essentially, just think of kind of distributing this power. This m needs to go to the a and it needs to go to the b. So we would write it as a to the power of m and b to the power of m. And usually you'll use this rule in conjunction with the other rules we just went over. So for example, we have y to the power of 4 x squared, and then everything's being cubed. So we need to distribute this 3 into both the y and the x. But since both of these variables already have exponents on them, we have to do our power of a power rule. So this is like doing 4 times 3. So we get y to the 12th power. And then I need to do 2 times 3, which is 6 for the x. So you're distributing that 3 into both of them. If you want to, you could write it separately and do y to the 4 cubed. And then you also have x squared being cubed, and then it becomes your power of a power rule. But essentially we're doing the same thing, and we're just trying to do it as quickly as possible. So one thing to note is that numbers count as their own base. So when I distribute this 3 in, I also need to bring it into the 2. So think of this -2 as having a power of 1 on it, and same with this y. So really I have 3 bases in here. So I need to bring this 3 into all 3 bases. So I need to do -2 to the power of 3. I need to do y to the 1 to the power of 3, and I need to do x squared to the power of 3. So I'm bringing that power on the outside to all of the bases on the inside. So with -2, when I cube it, remember that's like doing -2 times -2 times -2, that equals -8. So we can simplify that all the way so that there's no longer an exponent on it. And then for both of our variables, we're going to just do our power of a power rule where we times the 2 exponents. So this one's easy because 1 times 3 is just 3, so we get y cubed. But then here, 2 times 3 is 6, so we get x to the 6. And that would be your answer. So just make sure you're bringing that power into the number separately and not just to the variables. So same on this one, I need to bring the 3 into the power of 2. And I'm not going to do 2 times 3. Remember, that's 2 to the power of 3. So that's different than just doing 2 times 3. And then I need to bring the 3 into the x cubed. So I'm going to have x cubed again. And then I need to bring it into the y, which right now the y has a power of 1. We just don't write the 1. Then I need to cube that as well. So for this one, 2 cubed, again, that's not 2 times 3, it's 2 times 2 times 2, which is 8. And then here we have x cubed and then cubed again. So doing our power of a power rule, you're going to do 3 times 3, which is 9. And then on this one, we just have the power of 1 times 3, which is just 3. So we get 8x to the power of 9 y cubed for our answer. Okay. Sometimes, let's take it one more step farther. Sometimes we have terms in a fraction like this. So see, we have 3 terms and 1's in the denominator, 2 are in the numerator. We have this exponent on the outside. We still need to think of distributing that exponent to all 3 bases that we have. Right now, the C and the D don't have an exponent, so you can think of them as being a power of 1, but I need to bring that 3 into all 3 bases. Again, you can write it out if you want. That would be like a b squared being cubed, and then a c to the 1 being cubed, and then a d to the 1 being cubed. You don't have to do that step. I know it gets kind of annoying having to write all that out all the time. So if you can do it in your head, great. That's kind of what we're hoping for. But now we're going to do power of a power rule where we times the 2 exponents together. So 2 times 3 is 6. So we get b to the power of 6 here. And then 1 times 3 is 3. So we get c to the power of 3. And then on the bottom in the denominator, we have d. And then the power of 1 times 3 is 3. And that would be your answer. So you have b to the 6th, c to the 3rd, and over d to the 3rd. Okay, so we have a bigger one this time on example 14. We have those coefficients. Remember, these coefficients count as their same base. So I need to bring this square into the 3, and I need to bring it into the x squared. I also need to bring that square into the 4 and into the x cubed. So that will give me 3 squared, and then I have x squared being squared again on the top, and then on the bottom I'm going to have 4 squared. Remember, it's not 4 times 2, but 4 squared. And then on the bottom we bring that square into the x cubed, so we'll have x cubed being squared again. So as we simplify the numbers, we can get rid of the exponent by just doing 3 squared, which is 3 times 3, which is 9. And then we have our x squared being squared again. So we do our power of a power and we times those. 2 times 2 is 4. So we get x to the 4th. Then on the denominator, we have 4 squared. So not 4 times 2, but 4 times 4, which is 16. And then we have our x cubed being squared again. So we're going to do 3 times 2, which is 6. And there is a way to simplify these x's where you have the same base being divided, but we are going to do that next time. So for now, we're just going to stop. Okay. Let's just try a couple more that are a little bit more difficult. These are going to be a combination of all of the rules that we've done. So on this one, we have one group times another group. Notice we have numbers, x's, and y's. I like to break them up into their like terms. So let's do our numbers first. I'm going to do 3 times 4 in a group. And then I have x to the 4th and x to the 4th again. So I have x to the 4th times x to the 4th in a group. And then let's do our y's. We have y cubed times y. And then you just go and simplify each group. So 3 times 4 equals 12. Here we have the same bases. Notice there's 2 bases being multiplied, so this is the time when you add the exponents. So we're going to do 4 plus 4, which is 8. And then here, this is like a power of 1. It's just not written. But we have y to the cube times y1. So 2 bases means we add the exponents. So 3 plus 1 is 4. And that would be your answer. Okay, on this one, we have one term, and then we have times m cubed times b squared. So we only have the m's here that are the same base. We don't have another set of b's. So really all we can do is do those m's together. This is like saying I have m to the power of 7 times m cubed, and then we just have this b squared. So again, when there's 2 bases being multiplied, that's when you add the exponents. So 7 plus 3 is 10, and then since we don't have any other b's, we can't really do anything different, so we just keep it as a b squared, and that would be your answer. Okay, let's look at some. So those were the product rule where you have 2 bases and you add them. Let's look at the power rule, power of a power again. So these will have 1 base raised to 2 powers. These are when you multiply. We need to remember that numbers count as their own base though, so think of this 3 as coming into the 3 and then the a squared as well. So if I write that out, I'm going to have 3 cubed, but then I have a squared being cubed again. So when that happens, you're going to times those two powers together. So I'm going to have 2 times 3, which is 6. And then in the front, 3 cubed, that means to do 3 times 3 times 3, which is 27. So we have 27a to the power of 6. And then on this group right here, notice how this 2 is not inside the parentheses. For this power to be applied to it, it has to be inside those parentheses. So this square is not applying to this 2 since it's just hanging out front. This 2 only applies to anything on the inside, so we only need to bring it to the 3, versus on this one, the 3 was inside the parentheses, so we bring that cube in with it, but not to the 2 since it's on the outside. So let's keep our little plus sign going. We're going to just keep the 2. Again, it's not going to be applied to this power of 2, but then for the a, we have 3 times 2, so we get a to the power of 6. So our final answer, again, that 2 doesn't change. We will have the 27a to the 6 plus 2a to the 6. And then now, technically, we could go one more step in simplifying. Since these are both a to the 6's, we can combine those like terms. We're saying I have 27 of them, but now I have 2 more a to the 6's. So total, I have 29 a to the 6's. So if I wanted to simplify all the way, this would be my final answer. So remember, we want to try and simplify as much as possible. So since these are like terms, we can combine the 27 and the 2 for a total of 29 a to the 6's. Okay, let's try this last one. Notice this -3 is not inside the parentheses, so that square does not apply to it. So it's just going to hang out in the front. But then this square needs to come to the a, it needs to come to the x, and it needs to come to the y. So this a right now has a power of 1, same with the y. So when I bring that power in, I times it to the other power. So 1 times 2 is 2. And then I have x cubed being squared, so 3 times 2 is 6. And then again, we had that power of 1 on the y, so 1 times 2 is 2. So you don't really need the parentheses anymore. You can just write it as -3 a squared x to the 6 y squared, and that would be your final answer. So just pay attention to if there is a number outside of the parentheses versus inside. So inside you do bring the power to it. If it's outside of the parentheses, you do not. So that's an easy little trick to get caught up on. So those are the 2 rules we're going to learn today. This whole unit is going to be based on different exponent rules. So next time we will learn a couple new power exponent rules. But go ahead and get started on your homework for today. And if you have any questions, as always, feel free to email me and reach out, and we can set up a tutoring session. So hope you guys are doing good. I will talk to you later. See ya.